Hello, everybody, and welcome to our 105th webinar in our series. We've just been going like crazy, just been steady. Tons of great guests. We've got another one today. Ray Phillips is joining us. I think he's here for I think this is his fifth webinar that he's done with us, and I really appreciate a guy that is as busy as Ray is, as well as many of our other co-hosts that come in and work with us and share their knowledge. It's really a special thing that a lot of the information you're getting here is just amazing, and from all of our co-hosts, and I really appreciate their time coming in here. This one is going to be all about validating setup changes using racing simulator data. So we are in the middle of kind of a sub series of data analysis webinars where we really are focusing on not the button push on how to make certain functions work. We've done a lot of that, and we'll do more in the future. And there's lots of videos. Many of these 105 webinars you can go back and find that information, where we'll give you links to certain webinars that may touch into that as the day goes on today. And down in the description box below, if you find something you don't know how to do that Ray mentions, it's probably a webinar on it, and there's links that are going to be available to help you do those. But so with the subset it's all really about data analysis, getting the most out of your data from the data analysis side. So it's been great to have folks like Ray come in here and chat with us about this kind of a thing. So let's go to our introduction slide. Ray runs a company called Precision Driving Analytics, and he is, as I mentioned a minute ago, he's super busy at this time of year. Obviously, he's owned this company for quite some time. Been involved in motorsports. He's a lifer, right? 27 years. The driver for much of that. I find a lot of the good engineers and data guys and all of those have some driving in their background. They can relate to the driver that they're trying to talk to, or the engineer that they're trying to talk to, and I think that's an important thing. And Ray has experience on both sides of this, so that's pretty cool. Data engineer for the 2019 Ferrari Challenge Championship team. That's there's a good feather in the cap. And again, 5 times as the co-host. And there's his own daily driver, right, Ray? A picture of your daily driver there. Ray, tell us a little bit more about you and what you do as we kind of get started here.
Yeah, I mean, what you said was correct, Roger. I am a lifer. I love racing. I got my racing license in '97. I raced Formula V's for 14 years, and then Formula F for another 3. I built my Formula F, converted it from a F2000 car to a Formula F with a Honda Fit motor. When I built that car, I put a full-blown data system in it. I'd been using data systems in my Formula V, but in that one, I really went as far as I could on my budget and just really learned a lot about analyzing data and how to make myself go faster, and then realize I can help others do that too. So I actually think I like helping others go faster now more than I like driving. It's just, to me, it's really cool. I just love the data, and I love trying to figure out different ways of helping people go faster.
And very, very interesting. A number of parallels there between you and I, right? Since I stopped driving, I raced off-road cars for a long time, and I stopped driving in 2006, and have really enjoyed the second part of this even more than the driving, and like you do. And another thing we have together is you started off in such high horsepower cars as a Formula V, right?
Yeah.
And my the first class we ever raced in off-road was they called it Class 9 at the time, but it was the stock ish, for the most part, 40 horsepower Volkswagen engines, and which I think was the engine that you ran in your Formula V's, I believe, as well, the 1200cc Volkswagens. Yep, so a lot of the technology I remember listening to and chatting with Formula V guys as we were trying to build our little 1200cc single port, little tiny intakes of our 40 horsepower engines to make more power. And we got a lot of that technology from what you guys were doing. And I've talked to another Formula V guy that'd been around it forever. I remember the time that I learned, and we had engine builder that had an engine dyno, and we took these steel balls and knocked them through the intake manifold, which is turned out it was just a very, very standard thing in what you were doing back then, but it was new to us. So again, kind of a link together between us. So that's kind of cool.
Yeah.
What we're going to talk a little bit about, by the way, everybody, when you Ray's contact information's there, we'll have a slide at the end of getting a hold of Ray. Ray has a couple of things. Robbie just put the link into the chat box, and it'll be down in the description box below if you're watching this later on YouTube. What he does is he offers a service, and there's a service tab on his page, and you can go in there, and a lot of the stuff that you're going to see today, the profiles, the math channels, it's one of the things that that Ray offers as a service is send him some of your data, he has a conversation with you, figure out what you need to do, and then he sits down and builds you a process, user profiles, math channels, ways of looking at the data to help do some things like he's going to talk about today. So that's a service from Ray. Go to the website or give him drop him an email there at the email address that's shown there. I think we even have a phone number at the end of the process as well. So everybody, there's a lot of valuable knowledge that Ray has in his mind that he can share to help you do better work with your data, and it's really quite reasonable. So what we're going to talk about today is, of course, racing simulation. He's going to use the Assetto Corsa software to do this, but the process is the same, right? And more or less, the process isn't exactly the same, but the end run, if you were to use iRacing or any of the different ones that we here at AIM do, you're going to grab some data. Ray's going to talk about how to get to that data and how to do it with Assetto Corsa, and then of course the focus of what we're going to talk about here is analyzing the data. But I'm going to turn it over to you, Ray. I'll run the mouse here for the presentation side. We're going to go through the presentation. We're going to give you some background information, some cool things, and then we're going to jump into live data and actually look at 4 or 5 runs that he made in the simulation. And take a look at what it did for the handling of the car and some different things. So I'll turn it over to you, Ray. You handle that. Let me know when you want to change slides, and we will go from here.
All right, sounds good. So yeah, I'm using Assetto Corsa here. I mean, I've done quite a lot on iRacing as well. I actually kind of like the feel of the cars in Assetto Corsa a little bit better, but iRacing is very good too, especially if you're going to be actually racing. iRacing is great for that. But anyway, all this data is from Assetto Corsa. In order to get the data into AIM, it's really simple. The first thing you need to do is find this telemetry _dump.act file, and gave a little address there of how you can find it in your documents. That file is overwritten every time you drive in Assetto Corsa. So if you do want to look at data, make sure you do the import that we're going to talk about here into RS2 analysis before driving again. Okay. If you keep driving, then you'll have everything in one, and that's fine too. I personally like to have them separated, especially if I'm making setup changes though. You can see at the bottom here, there's a little screenshot. All you have to do is go to File, Import Assetto Corsa file, and that's it. Then it'll pull it in, and just like you're downloading data from a car, it'll ask you, who's driving, what's the track, blah blah blah, and then you just import it. So it's pretty simple.
There's Robbie will probably put the links up here in just a moment, and we'll certainly have them later in the description box for YouTube. We have a website that on our aimsports.com web page where we talk about simulation racing, and then we've got documents for the 3 main types of sim racing that we do support, and walks you through all the steps, and including this one here. So we've got a lot of good documentation on how to do this as well.
All right, next slide.
Here's what we're working with, right?
This is it. So since I support a Ferrari Challenge team, I know a little bit more about the Ferraris. So I chose the 488 GT3, powerful car, downforce, and as you're going to see, there's lots of things we can change as far as setup.
And
So
Kyle has a question that kind of fits in right here that maybe we can ask real quick, but he doesn't know a lot about simulators, but how accurate can their modeling of reality be, right? The tire modeling, suspension and all that, and the reaction of the cars. You know these cars fairly well. On this particular car, how good do they model everything?
well, I don't have GT3 data to compare against in real life, but I can say that it's just getting better and better. Maybe 10 years ago, it wasn't that great, but I can tell you it's pretty good now. And certainly, I think you'll see that there's a lot you can do with simulators, not just, trying to learn a track, there's a lot you can do with the data, and really you can do more with the data from simulator data than you can in real life data, because there's just so many quote sensors on the sim car, so it's really a great way of figuring out the dynamics of a race car.
Yeah, and we're certainly not trying to prove something here, but we're gonna look at data where Ray has done some of these changes, and we're gonna see what the differences look like. And Ray will even give us some feedback of what it felt like from inside behind the steering wheel of his simulator as he was doing it as well. So perfect. Here we go. We're gonna go through some slides here. Ray, what are these set of slides really trying to accomplish for everybody?
Well, this is just kind of showing the initial setup of the car. So I just kind of want to show how many different things can be changed. The ones that we've highlighted in yellow are the ones that I actually do change in this process. But you can see, as we go through, I'm going to go through these pretty quick. You can go ahead and go to the next one.
And what's also interesting about this is, of course, this presentation is available for everybody if they want to download it. And if you have Assetto Corsa and use it, you can follow along with some of these changes that Ray did and get a good handle on it. So he's giving you all the settings that he changed as well, and the base setup. Okay.
All right. So yeah, you can change front toe. Now, one thing to keep in mind, when you're in Assetto Corsa, there's a little window that pops up, and it tells you all the different settings. They may not match exactly to the little clicks and all where you actually make the change. And it's showing toe in degrees. And I think most people think of toe in millimeters. So 0.08 degrees is equal to about 1 millimeter. Okay. So, it's a pretty simple conversion once you know how to do it. But that was one I had to search to figure out what the heck was going on with the toe.
As a little bit of a math nerd, I think that you almost have to do that, right? Because you could have different size wheels, or people could be measuring in different spots, and that would affect it. But the degrees are the degrees. Right. So I get it.
Exactly. Yeah. So anyway, so that's the front toe and the rear toe. 1 millimeter in on front, 1.5 millimeter in on the rear on both sides. Front dampers, just all the different bump and rebound settings. And then you can go on to the next slide. And rear dampers, drivetrain. You can see there's a lot of stuff to change here. So which is if you look at that, the screenshot, the window in the middle there, that's where it's telling you all the different settings of the car.
Okay.
Most of them anyway.
Okay. Let's go to the next one. Here's one that you'll end up making quite a few changes at.
Right. So, you got the brake bias, the shock travel range. The reason why you have shock travel range is whether or not you want to use packers. If you want to stop the shock short of, the ride height, so that you don't bottom out the car, that type of thing. Front ARB, rear ARB, ride heights,
anti-roll bar, sway bars. Yep.
Correct. Yep. Wheel rates are really your spring rates. You can, if you have a spring rate, the motion ratio, then you can get the wheel rate, and you can go the other direction as well. So I've actually kind of calculated, knowing the spring rates on the Ferrari Challenge car, how those match up to the wheel rates in Assetto Corsa. I've done quite a bit of study on that type of thing. But yeah, so that's what the wheel rates are.
Yeah, there's a couple of just real quick ones, but Packers was a question that you threw out the word, and I see in the chat a couple of people use it, but all they are is little, neoprene shims, plastic shims typically, where it just limits the travel of the shock. And if you don't want the front tire to come, front or rear, to come up
Yes,
so far, and it keeps the splitter from hitting the ground, or it keeps a level platform for aero reasons, or some other thing. So it's just a tool
yeah,
that the tuner guys will use to limit that up travel.
that's correct. Yeah.
Perfect. Okay.
I see a question. How do you factor in topography into the field in the simulator setting? Um, Actually, I use virtual reality,
Oh,
and virtual reality, the first time I used it, that was the first time I ever felt elevation change in a simulator.
interesting.
So it's amazing how that tricks your brain into feeling, the elevation changes. So that's how I
Interesting.
do it.
Amazing how powerful the brain is in those, right? And how good the simulators are nowadays too for the
Yeah.
visuals. So
Yeah.
very, very cool. Okay, let's go to the next one. Here's the big question, right? And some of the stuff that you're going to be changing is and what we're going to follow along in the data is understeer, oversteer, driver feedback, from the steering wheel, driver asking the car to do something. Give us a little bit of an idea of what is understeer, what are we going to be looking for, and for the rest of our webinar today, the kind of stuff we're going to look at.
Yeah. So first of all, the setup that we just went through is not a very good setup.
On
It
purpose,
has
maybe. All
it
right.
has a lot of understeer, and I did that intentionally because understeer is something that most people end up having to dial out in one form or another, whether that's driving differently or different setup. Um, so it's just something that is always a problem with every race car in some fashion, I think. Um, so what is understeer? I know a lot of people have some pretty strong feelings about what understeer is, and that it's always bad. But if you look at it from an engineering perspective, I guess, understeer is is basically just well, let me back up. If you have a steady state cornering, or steady state cornering state is assumed and there's no slip angle at the front or rear, then the steering angle required to negotiate the corner is called the Ackerman steering angle. So it's basically neutral steering is what that is. You're driving really slow, you've got no lateral G's built up, no slip angles, and it's just the amount of steering that's required to get around that corner. That's neutral steer. Okay. So authors Milliken and Milliken give the following definition for neutral steer, understeer, and oversteer. So neutral steer is where your steered angle equals your Ackerman steering angle. So that's what we're going to be comparing against. So if the steered angle is greater than the Ackerman steering angle, then that's understeer. And if the steered angle is less than the Ackerman steering angle, then that's oversteer. So it's a great way of just coming up with a number, of what that level of understeer or oversteer is. And you can find this definition in Jorge Seeger's book, which is right here. Great book if you don't have it.
Fantastic book. Fantastic.
Yeah.
We had a webinar with Jorge at a while back, and if you have a chance, go and watch that. He's a very interesting and smart guy.
Yeah. Yeah. So Ackerman, like a lot of people think of, is different than the Ackerman steering angle. I saw a little bit of chat going on about that. So if you look at what's in Jorge's book, he's got a diagram there, but effectively it's just the angle that the car ends up driving around the radius with zero slip angle and no lateral G's effectively.
And
So,
even bring this down to something that I can understand. Basically, it's what the driver's asking for versus the rotation angle of the car, right?
right.
Kind of based on the outside front tire in effect. So
Yeah.
kind of complex, but at the end of the day, it's what you're asking for versus what mathematically the car is needs to be doing. So
Right. Yeah.
okay. Perfect. And we're gonna demonstrate. Ray is gonna demonstrate a lot of that as we kind of go here. Okay,
Right.
let's go to the next slide a little bit. How do we get to this magical number that we've been talking about?
Right. So you need to compare the theoretical, which is neutral or Ackerman steering angle, amount of steering required to the actual steering input. So as we said before, if the actual steering input at the wheels is more than the theoretical amount of steering required, then that's understeer. If the actual amount of steering input is less than the theoretical amount of steering, then that's oversteer. So again, we have to compare the steering at the wheels to the theoretical amount of steering. And this is the formula to come up with a neutral or Ackermann steering angle. So it uses the wheelbase, the speed, lateral G's, so those are the three elements, channels that you need. And almost every race car has those. You just got to measure the wheelbase. And you have to be really cognizant of your units, which is why I put, what each of these little sections come up with. So wheelbase in inches, you're going to get that into feet by dividing by 12. Speed in miles per hour, you're going to get that into feet per second, but then you're going to square it. So it's feet squared over second squared. Lateral G's, you're going to get that into feet per second squared. And that, when you take an arc tangent of all that, you get radians, but then you want it in degrees so that you can compare it to your steering degrees. So then you multiply it by 57.2958. So it's a lot, but once you know the formula, it's pretty easy.
And I'll just remind everybody that the data that we're sharing, we'll have some. I think we've already put the links up. Robbie will probably put them up again, and in the chat, and you'll have them down in the links below. We've got the data, we've got the profiles, so it'll look the same as when we're looking at this in live data here in a moment, and it's got the math channels. So this math channel, while you can build it yourself if you wish, you have the ability to import it and use it in Ray Studio from Ray.
Yeah. By the way, there is other ways of calculating understeer. If you have a yaw sensor on your car, you can compare that to calculated yaw. And there's a couple of other ways. I suppose you could drive the track really slow and come up with a steering angle for every corner, and then compare to that. But this is my preference, and when I go through it, I think you'll see why. So,
and we're going to show you how it works. Ray will demonstrate that it's a successful way of doing it.
Yeah.
Okay, so let's go to the next slide. Continuing.
Right. So you've got to get the steering at the wheels. So this is how you do it. You just take your steering wheel angle in degrees, divide that by your steering ratio. On the Ferrari, that's 11.2. But if you have a variable steering ratio, then it becomes a little bit more difficult. But you could also put the front tires on turn plates and measure it. And if you have a variable steering ratio, then you definitely need to do that because it's going to change as you turn the wheel. So if you have a variable steering ratio, then you need to create a custom sensor and always take your measurement at the outside wheel. But once you get that calculated, once you know you're steering at the wheels, then it's just a matter of taking the absolute value of the steering at wheels and subtracting the absolute value of the neutral steering. And that gives you understeer and oversteer, understeer being positive, oversteer being negative.
And if you if Ray went by that fairly quickly and you have any questions, drop us an email. Basically, if it is a straight up, you turn your wheel 90 degrees and it moves your spindle angle to be 9 degrees for 90, it's a linear ratio, right?
Right. Yep.
Can do that with a simple mathematical part of the formula. If it is changing, it's non-linear, we'll have to build that into a custom sensor. And if you have any questions about that, drop me a line and I'll help anybody work through some of that a little bit more intricate side. So okay, perfect. Okay, you ready to go to the next slide?
Yep, let's do it.
Okay, and I think the next slide just says that we're going to go to some live data.
Yeah. Well,
okay,
this is your data, right?
It happens to be some data. I was looking to do some screen capture, so I just took a Mazda MX-5 Cup car and created the channels that Ray's talking about and applied it to a different car than even Ray is. It's a good example of that this stuff works across the board. It's not Ferrari specific, right?
That's right. Yeah, no, you should be able to do this with any car. So
exactly. You need the steering sensor for the comparison, but you certainly can build the mathematical steering number
right.
with just virtually any of our data systems.
Yeah.
Okay, so let's bring up the data.
Data.
And I'm going to give Ray the control of the mouse here. And Ray is going to, let's do that. Ray's going to kind of take over and talk us through. We've brought in some data. This happens to be test number 1 that we're going to look at. Assume it was a, maybe you can help us out a little bit. I'm assuming it was a run at the settings that you just showed. And then you're going to start making changes, and we're going to look at the differences and walk through 2, 3, 4, maybe as many as 5, depending on time, and show different changes and how it reacted. And hopefully, Ray, you will also give us some feedback of what you felt in the simulator as well.
I will try to do that.
Okay, go at it.
All right. First of all, I'm gonna bring up the math channels that I'm using, just so that everybody knows what we're looking at here. So I've got steering velocity. It's just a good way of looking at what the driver is dealing with his steering wheel. Throttle velocity, that's going to be used in a future math channel. Combined G's, I think everybody knows what that is. Reversing longitudinal G, steering at wheels, this is what I was talking about. So I've got the steering angle and I'm dividing it by the steering ratio of 11.2. Neutral steer, so this is that formula that we were looking at. So you can see I'm just using the wheelbase in inches and then getting it to feet, the speed, lateral G's, and converting everything into degrees by multiplying by 57.2958. The amount of understeer or oversteer is, again, just the absolute value of the steering at the wheels minus the absolute value of the neutral steer. Now, I like looking at the amount of understeer and low speed corners, mid speed, and high speed. And how I define that is subjective. In this case, I'm saying a low speed corner is less than 70 miles an hour. You can see that here. Mid speed corner is between 70 and 100 miles an hour. High speed corner is over 100. Okay. Lifting is simply if you've got more than 30% throttle, but your throttle velocity goes less than 0. So basically the throttle velocity is negative. So that shows that you're lifting off the throttle. Okay. This one we're going to look at quite a bit. If lifting is happening, then is understeer greater than 3 when it's happening? And if it is, then show us a 1. Okay. So what I'm trying to do here is figure out just how bad is the understeer that the driver is experiencing. Is it enough for him to lift off the throttle because he feels like, he's going to go off course or something to that effect? Total understeer is simply just adding up all the understeer over a given lap. Okay, so it just gives me a number that I can compare against. So those are the math channels. So now I'm going to go into the user profiles I'm using. So this is one of the first ones that I like to look at when I'm making setup changes and trying to dial out understeer or even oversteer. So here's our total understeer, and you can see, every lap what that is. Here's my fast lap, lap 12. I like to look at the minimum speed and the maximum speed. I also like to look at the understeer, the average, not 0. Now, I'm also looking at this when the lateral G's are greater than 0.5. So I want to make sure that I'm in the corner when that average is being calculated. And then the maximum understeer level. And then the same thing for medium speed corners and for high speed corners. So this is going to be our baseline, when we start to make setup changes. So here's the understeer map. Good thing about this is, you can see visually where the understeer is the worst. And you can even see, whether or not it's happening, mid corner, exit, whatever. Now I like to look at, think of bad understeer as over 5. Okay. And this is just kind of based on experience. Usually when the understeer gets over 5, that's really when you start hearing the driver complain, that he's got too much understeer. But understeer is a funny thing, or the level of understeer is a funny thing. You may have a driver that's really happy with a car that's free, and his understeer level may be 4 or even 3. Okay. At that point, that driver is complaining about it. But, each driver tends to have their own number, subjectively, I'm using 5 just based on my experience that when I see understeer numbers over 5, usually that's a problem to the driver. Okay.
And we're going to look at your data as we go, and you're also not only going to quantify, that number of something that you kind of know, and it kind of works, but where in the corner does it happen is also
Right.
a big part
Right.
of this.
That correct. So you can see this is of course Laguna Seca. You can see like in turn 3 here, the understeer is starting pretty early and it's all the way through the corner, kind of more mid corner at turn 4, more mid corner to exit at turn 5, a little bit at 6, definitely
Yeah.
big understeer at 9, not so much in 10, but it's still there, and not so much at 11. However, when you see the colors changing, this is another good thing to look at. That means that the driver is doing something with the steering wheel to mitigate, basically oversteer. He's probably feeling oversteer, but from an engineering perspective, it's still in the understeer range. But when you see those color changes, it tells you, that the back end is trying to do something, at that point, and the driver is making steering corrections.
And Ray did a video for a webinar with us that we'll probably post a link up to, that where he spoke a lot about this track report function, and a lot of people don't have not used it in the past a lot, and Ray got a lot of people to choose to start using it a little bit, and we'll make sure we get a link up from that webinar.
Yeah. So there's a question about how to determine driver's influence. Well, I mean, that's a tough one because when you're driving in a simulator and you're making changes, or even driving in real life and you're trying to decide if setup changes should be made, you should be driving close to the limit, maybe not at 100%, but as close as you can be comfortably where you're not making mistakes. And you should be able to feel when the car is on the edge. If you're still learning the track, then that's not the time to decide, if you should make setup changes or not. But as setup changes are made, obviously the driver is going to drive a little bit differently, but the overall goal is the same, right? You want to go faster, and you want the driver to be more comfortable in the car and build his confidence. So, I've always said that the best setup is the one that gives the driver the most confidence. So that's really the target. And, there's not everything is going to show up in the data like that. In this case, I was the driver, so I've also going by my feeling. And the whole intent of this is for you all to practice this in a simulator as well. But even in real life, you should be able to analyze your lap and decide, are you making mistakes, or is this the car preventing you from, going faster?
Okay.
All right. So understeer histogram, I really like using this one too. So this shows the percent of time that the car is at different levels of understeer. Okay. So I mentioned the number 5. Here's our number 5, and you can see quite a few bars above that actually getting up to 7 here. So that would be, a red flag to me if I was looking at real data as well. So we're going to be using this for some comparisons. Throttle histogram, how much time are we spending at full throttle? In this case, our number is 57.1. That's, basically at the full throttle mark. And how much time are we spending, at all the different levels in between? So
this is a tool that a lot of people have used for a long time, and I think it's still a great tool, and I'm glad to see that you're showing it and using it. If the driver's comfortable, that if the changes worked, whether or not you even quantify it with some of the tools you're going to talk about today, the driver will be at full throttle more, right? And so it's I'm glad that you're using that as a part of your toolbox to look at the stuff we're doing still.
Yep. All right, so handling analysis. Here's our, the purple or pink is the neutral steer. The yellow is the actual steering at the wheels. I don't know if you can see the blue very well, but that's our total understeer. And then this is the amount of understeer, which is simply just that calculation. So that you're seeing the gap there between. So you can see how above 0 is understeer and below 0 is oversteer. So you can see right here, that's a little bit of oversteer right there. And that's probably the corkscrew.
Yep, it absolutely is.
Steering velocity, how quickly you can see at that point where there was oversteer, you can see that's where the fastest steering velocity is. We have our throttle, and then the pink is the understeer lifting. So lifting while there's more than a level of 3 of understeer, okay? And then just the speed at the bottom. So these are the 5 user profiles that we're gonna end up using here. We're gonna pull up second test and do a comparison.
Okay. So if we haven't, if you haven't opened up multiple tests as Ray's opening this up, all he did is go back to the test database. He clicked on, just added another one, and then you get the tabs across the top of all the different functions where you can look at just test number 1 in this case, the one we had open, test number 2, the second one he just added, or you put them together with a test compare tab, which is pretty that same functionality is all through the software. So he's jumped into his understeer report profile, test compare. He's going to look at, okay, I've made some changes. What were those changes, Ray? And then boom, here we are.
Yeah. So the change that I made is I changed the front sway bar. So I went from full hard to medium. Okay. So that change should help the car in high speed corners. It's going to make the car more responsive, turning into the corner as well. Sorry, it's going to be a little bit less responsive turning into the corner, but it's going to help it in the long high speed.
But add grip overall in the middle of the corner.
Grip overall. That's the intention anyway.
Okay.
So here's our total understeer, and we can look at all the different laps, but I'm just going to focus on the high speed, the fast laps of each session. So one, we took off about 4/10, so that's good. Our total understeer dropped from 131.55 to 121.84, which is good. Picked up a little speed in the minimum speed. Exactly the same as far as top speed. Understeer on average was a little bit higher for low speed corners, about the same max, so it didn't really affect the low speed corners much. Mid speed corners, now we're starting to see an effect. 2.3 average compared to 2.94, 5.57 max compared to 6.29. High speed corners, average didn't change much. In fact, it went up a little bit, but the max went down. So overall, that looks pretty good. That looks like a good change. And of course, I felt that change as well. I could feel that the car was better where I expected it to be better. But this validates it. And that's kind of what we're going through here, right? We want to validate what we're feeling in the car, because sometimes, we're all human. We get our minds get a little muddled. So,
and what I think is so interesting about this, and I don't want to take too much of Ray's time chatting about this, but we've talked a lot about the squiggly lines and being able to read how those are. And what Ray has done here and is sharing with everybody, not just with explaining it, but sharing the math channels and the user profiles. There are other ways to quantify it in real numbers, or in this case, a visual of the track map. And I think that's just a fantastic thing that he is helping all of our users do.
Yeah. All right. So here's the understeer map. And remember, we were looking at the colors. This is the first session. And just quickly going to the second session, you can see turn 9, especially going back and forth, how that's changed. Turns 3 and 4 have changed. 5 actually looks like it's got a little bit more. Turn 6 is better. So we can just, kind of go back and forth. And this is really how I analyze it. I just go back and forth and look at the different colors and say, yeah, okay, I think that did help. That did make a good change.
It matches with what you felt while in a simulator as well.
Right. You can see there's a little bit more oversteer coming out of turn 3. But it's not enough for me to say, this was a bad change. Understeer histogram. take a look at this. We'll do test compare and then measures and then per lap color so we can see the difference. So the faster lap in test 2 is orange and the other one is yellow. So you can see how the numbers dropped, across the board.
In the critical area of the measured understeer. Yeah.
Yep. And you can actually see that the oversteer also picked up at the bottom too. So yeah, so far everything is falling in line with what we would expect. Throttle histogram. It's slightly more full throttle. That's 57.5 versus 57.1, but more full throttle or more throttle in the areas of, you say, 60 to 90% too. So overall benefit there, I think. Handling analysis. I'm going to focus in on the understeer lifting. So this was the first session, and this is the second session. So you can see, I'm having to lift less due to feeling that understeer. Okay. And again, just going back and forth between the two. And of course, you're seeing it build up in some corners where now I'm lifting more here and not as much here. But overall, the net effect is a benefit where in total, I'm not having to lift as much. Okay.
And interesting that all of your, it's what the data shows as well, is a lot of your understeer is happening from the middle of the corner out. All of these lifts that you're having to do here are happening on the exit of corners as the car's understeering.
Right. So let's go to the test database again, and I'm going to close test 1. And I'm going to open test 3. And in this case, I am setting the rear bar to medium. Okay.
From
so
what?
Actually,
from
soft.
From soft. So you're stiffening up the rear anti-roll bars. And okay.
That's correct. So this one's a little bit interesting. The car felt a little bit better to me, but as you see here in the data, it's not going to be as much of a difference. Our total understeer did go down. All right, so that's good. I've only gone, 2 100ths faster. So it's not like I took a big chunk of lap time off with this change. Minimum speed increased a little bit. Maximum speed actually went down. So that's not very good. Understeer average and low speed went down a little bit, but the max went up. So that's not real great. Understeer mid speed went down a little bit on average, but the max went up. So again, not great. Understeer average and high speed stayed the same. It did come down a little bit in the max for high speed. So that's good. Okay. So kind of a mixed bag there looking at this report. If I look at the understeer report, going back to test 2, these were our colors. And you can see turn 9 looks better. I've actually got a little bit of oversteer there, but there's some corners that are worse, like turn 4 here. That's worse. Turn 10 is a little bit worse. So again, it's kind of showing that mixed bag. Again,
turn 4 and 10 are very similar in the layout, right?
Right.
Where turn 9 is where, when I'm at Laguna, it's turn 9 that I go look for my understeer first, right?
Yeah.
It's such a long, steady downhill, taking weight off the front end, and you made that a lot better with this change.
That's true. And actually that's one reason why I chose Laguna Seca.
Exactly. So distinctive in with the different corners. It's amazing.
It gets so much understeer anyway. So, so anyway, so again, it felt a little bit better to me, but it wasn't like a huge change. So, but here's the understeer histogram. Again, we'll get the color so that you can see. So yellow is the faster lap. And you can see we had some benefit here. It got worse at the high level, and that's probably that high was the medium speed that had the higher number, right? Max. So that's probably what that is. But again, a little bit of a mixed bag. And then throttle histogram. So the blue is the faster. So actually, got quite a bit more full throttle, so that's good. Um, less time spent in the 70 to 90% range. But that's pretty good. I'm happy with that. Handling analysis. So again, this was test 2 and this is test 3. And again, we're looking at the understeer lifting. So I think it actually did come down a little bit,
Yeah, I do too.
Yeah. So there's a benefit there. So yeah, I mean, it didn't result in a big chunk of lap time coming off, but it felt okay to me. And there's some benefits here. It's a mixed bag otherwise, but it's good enough that I'm going to keep the change. Okay.
Or at least build on it, right? So
At least build on
maybe
it.
in real life you would we're walking through these 5 tests, but in real life maybe go back to the front bar and make a little bit different change and leave the rear where it was. You're going to go do looks like make sure everybody understands it in the comments. There is kind of what you're looking at, and
Right.
all of you are going to have this data later, so if you want it. Those are the changes that he actually did, so that makes it a little easier to understand it later.
Right. So in this case, I'm taking 2 degrees of rear wing out of the car. Okay, so this is test 4. So I'm going to go back to my understeer report. All right, so now looking at the total. So now I've got under 25 on my lap time. So that's another 4/10 or so off. So that's good. My total understeer came down. That's good. I didn't go as fast for a minimum speed, but I'm kind of back to where I was. So that's not too bad. I picked up 2 miles an hour at least. If you look at other laps, I'm up over 145. So that's an expected benefit of taking rear wing out.
Yeah.
Interestingly enough, I wouldn't expect the rear wing to affect low speed, but maybe this is capitalizing on the previous change. My average came down for understeer in the low speed areas, and my max came down in the understeer for low speed changes. So low speed corners. So, maybe that's just me getting used to that previous change a little bit more too, and the mid speed also came down. I would expect the wing to affect this. So average and max both came down. High speed, average and max both came down. So that looks good. I'm happy with that. Understeer map, again, looking at test 3 versus test 4. Now I've got more understeer in 9 and 10. Okay, so it's interesting because we're seeing the understeer numbers and all come down, but now I'm seeing more there. So why is that? Well, you can't ignore speed. So I'm going to go look at the handling analysis real quick and change this so we can see. So here's 9. Well, I'm going 6 miles an hour faster on test 4 lap. And here I'm going like 7 miles an hour faster. So that's why I've got more understeer in those areas, is that I'm basically driving the car into the corner a lot harder. In reality, there's probably, maybe I should be 5 miles an hour faster because I'm actually slower coming out of both of these corners. So maybe if I was 5 miles an hour faster, then I could keep my exit speed and, make sure that I've got that net gain. But, you always have to, sometimes go a step further when you're looking at data, right? You don't just assume that what you're seeing is keeping everything else the same. There's other factors that you always need to look at and make sure that what you're seeing is actually an issue, or is it okay? If you reduce, if your understeer number stays the same, but you take half a second off the clock, then your change was good, right? You went faster and the understeer number stayed the same, but that's okay. You went faster.
Speed and lap times are money channels, and at the end of the day, the money channel's the rule, right?
Right. Yeah. So if I look at the understeer histogram, so now, we're getting much closer to that 5 number that I wanted. The orange is the faster lap, and I'm about 5.5. and it doesn't seem to be doing much above that. So that's good. And it's lower from 4 to 5. So in the areas that I'm really concerned about, it's going in the right direction. So I'm happy with that. Throttle histogram. All right, so I don't have as much full throttle, but I'm kind of back to where I was too, so not sure if this is too terrible. I've got more throttle between 60 and 90%. So especially between say 80 and 90. So that's good. So I'm not too concerned that I'm, not as much full throttle there. Handling analysis. So test 3, that's our lifting, and test 4. So not bad, a little bit more back here, but again, I carried much more speed in those corners. So, I developed as a driver more understeer than I probably had to, and as a result, I had to lift some to mitigate that.
And those are also with your additional speed. Those are also
Yeah,
downhill corners, which will make that affected even more.
right. We got something's paused here.
Uh-oh. I don't think I can work it if you don't have the option to get at it. Are you hearing me okay?
Yeah, I can hear you okay.
Okay,
It's
let me
just,
reshare. Let me see if I can. Are you seeing? I'm dragging around in the. Are you seeing it change?
I am seeing a change. I think I'm back now.
Okay, go ahead and click once, and just to make sure you're okay. You're
Yeah,
running it again. Perfect.
yeah. There's just a little technology
Yeah,
hiccup there.
well, welcome to our world.
Yeah. All right. So let's go to the last setup. So last setup, I'm raising the rear ride height, which is a very common change to make if you're trying to get rid of understeer. And that should help the car in the lower speed corners as well. So if I go to the report, there we go. All right, so I got another 3/10 or so off my lap time. Total understeer numbers come down. Min speed's basically stayed the same. Max speed is basically stayed the same. More average understeer and low speed, but less max. Understeer in the mid speed, less average, less max. A little bit more average for high speed, but less max. Okay, so not so bad. Understeer map. So here's test 4, and here's test 5. So
yeah, that looks pretty good, actually.
Yeah, now we're getting somewhere. Now the car's feeling much better to me. I don't feel like I have to lift as much. The car's coming to me now. I'm feeling more confident with it. This little bit of oversteer here and here, that's mostly induced by me being on the throttle too soon, too much. So I'm not too concerned about that either. So let's look at the histogram. All right, so yellow is the faster lap. So now I got very little over 5. Okay. And it looks like the other ones are about equal over 4, a little bit more between 4 and 4.5. But no big extra oversteer either. So I think this looks pretty good. Throttle histogram. All right, so now I'm back up to 61.5. So I've built more confidence in myself to get to, full throttle sooner. And so that's brought me up to, 61.5% over the lap, so that's good. I'm off throttle about the same amount. Not as much here, but that's okay, because if I can be at full throttle longer, then that's what counts. My handling analysis. So here's test 4, and we saw the lifting here, a little bit of lifting there. But now only 2 times. So that's good. I mean, that's, I can continue to make changes with this car. but this is where we're stopping. But what I will do is I'll compare to the very first session and show what those differences are now.
Yeah.
So we started out, now the faster session is at the top. So we started out with a total understeer level of 131.55. We're now down to 88.46. Min speed is up a little bit. Max speed is actually down. No, sorry, up a little bit. Average for low speed is down. Average max is down. Average for mid speed is down. Max is down. Average for high speed is down. Max is down. So we've made improvements across the board. Been looking at that.
And you as a driver, what was your gut feeling as you were going through the process of these 5 tests? How did it feel to you?
Well, I felt improvement every time. Like I said, when I made the rear bar change from soft to medium, it felt a little bit better, but not fantastic or anything. The wing change was definitely an improvement. Raising the rear ride height, that was one of the best improvements, to be honest. But also that initial front bar change. So the car definitely felt better as I was making the changes, and that's the whole goal. So here's where we started, looking at the colors for the understeer, and here's where we wound up.
Yeah.
So pretty big difference, and it's very, very difficult to get rid of understeer in turn 9, and even in turn 10. So understeer histogram. So you can see we were getting up to 7 in the first test. Now we're just barely touching 6, and the percentages are lower too. So big difference there. So yeah, that's why I like looking at this histogram, is because when you know where your problem areas lie, it's very easy to zero in on those.
And that's an interesting one as well. While you did fix a lot of the larger understeer, you did increase just a little bit of oversteer down at the bottom half, right? Down at the 0.5, minus 0.5 and minus 0.1, which is naturally balanced car for the most part with that kind of horsepower. It's not bad.
Right. Yeah, exactly. Throttle histogram. So again, let me make sure my colors are right. The blue is the fast lap.
Yep.
So up to 61.5 versus 57.1. So I was off throttle a little bit more, but that's okay. If I'm at full throttle longer, that's really what matters when you're looking at the throttle histogram.
Well, as drivers will often do, if the car is understeering, they're on and off that throttle, trying to get the weight balance to do some things. And if it's showing you off the throttle, that you're not having to play the foot game to try to help the car rotate as well.
Right, exactly. You can see I'm spending much less time in the 10
transition times,
80% range.
Exactly. Perfect.
Handling analysis, again, we'll focus in on the lifting. So this was the initial test, and this is the final test. So just 2 lifts due to feeling the understeer in that case.
Perfect. So, perfect. I think you're ending at about the right time. It always is. It's always hard for me. We've got this hour to chat, and there are so many things that we would like to continue to. Where would we go next, right? There's 100 different things we would do, and I see some of that in the chat box. But we have lots of suggestions on, hey, I would probably try that. I'd do that, and Ray and I would probably do the same. But we have our hour, and we wanted to use it as good as we can as a teaching moment to walk our way through. So everybody kind of keep that in mind as you're watching some of these. Ray, I'm gonna let's kind of finish it up with a few of the questions that we have as we kind of go. And Kyle asked one fairly early. Does your model of over understeer have a way to factor in ideal slip angles of the contact patch? Very in-depth engineering kind of a thought process, but if the ideal slip angle of that particular tire on that car is 5 to 7 degrees, can you model that in? Probably not here, but the
No,
answer probably is yes, but probably not something we worked on here, right?
no, I think you've got to have some very expensive sensors in order to detect the amount of slip angle, that the front axle has versus the rear axle.
And then every tire is different. And I think it was John Block
Right.
that worked with us and had a couple of webinars that he specifically talked about that, where he worked with the tire company, and there actually is a lot of big brains working on getting that number, and then of course matching it and understanding it better. What type
Yeah.
of suspension does the 488 have?
I mean, it's standard coilover shocks, so, A-arm front end,
Front and
A-arm
rear?
rear. Yeah.
Gotcha. Okay.
So nothing special.
Pretty special, but
Right.
nicely done, but nothing special as far as
Right.
weirdness, right? Perfect.
Right. Yeah.
The can simulators drive themselves? Andy asked, like find the optimum lap. I do not know of that, but does it give
No,
you a ghost lap or anything, or is it just you comparing against yourself?
not this type of simulation. I mean, there is, calculating simulation tools
Yeah.
that you plug in, all the different dynamics of the track of the car, and then it'll tell you what the quote perfect lap time is, but it's not actually driving, it's coming up with a calculation. So,
Looking at radiuses and slopes
right.
and all the
Yeah.
different things and coming up with ways, and then they take that and go even farther. What's the perfect gearing? What's the the right
Right.
right approach as far as shock settings, and some real deep simulation.
Yeah.
The Art asked as a follow-up question. This one could be deep, so we'll give you the one sentence answer, right? At least in our opinions. But does the driver have more influence on understeer at corner entry than mid corner or exit? I'll take a quick shot at that because I've run into it all the time, and did with my son being a driver as well, coming from karts into sports cars. The driver had a huge influence on understeer at the corner entry, and almost always by over driving it, either driving it in too hard on the brakes and trying to do too much with the front tires, and it would create that problem. What's been your experience, Ray? Entry, mid, exit, understeer, and the driver inputs into that.
Yeah. I mean, I think the driver has more influence at entry, right? Because, he can trail brake into the corner and mitigate that by keeping, weight on the front tires. So if they're getting off the brakes too early, that's going to induce understeer, assuming the setup is an
Yeah,
understeery setup,
yeah.
coming into the corner. But once you start applying throttle, you're basically trying to get out of the corner, and that's the mid corner, right, point. So, yeah, I think the driver has most influence going into the corner.
And you see it both ways. One of them is what you just talked about, being a little gentle and maybe getting off of it and getting it right. And then I've seen aggressive drivers that are so hard that outside front tire is being overworked to the
Yeah.
point that understeer happens. And then when they finally do roll out of it, then they get the snap oversteer, tripping over the
Oversteer.
front
Yeah.
tires, and then that is just a whole process. That hole that you go down of trying to you got to work back to the early part of the corner to fix the first thing that went bad, right?
Right.
So,
Yeah.
and then James Colburn has a question, and I actually seen a little bit in the chat, and then I see it over here, and he's only been to Laguna Seca once. James being a many time guy that has helped us co-host. However, I experienced a sandy and dusty track, like driving in the rain, probably early, and then the track would get better as it evolved. How do you factor in track conditions into this understeer analysis? Do you think track improvement would happen to improve grip? How does the simulator handle that normal, especially Laguna, with cold or moist early, or dirty, and then getting warm and much more grippier in the afternoon? Do they model that fairly well?
I think iRacing does a pretty good job at that. Assetto Corsa, I don't think the track conditions are changing, as you're driving. And that's actually one reason why I like it, is because
Yeah.
that's one variable that's taken out of the equation, right? You can change the grip level of the track before you enter the session, though, and you can change the temperature. So if you want a less grippy track, you can take away some of that grip level. So, I mean, that is one way of getting around it. But in reality, this is just a calculation. As the grip level changes, if it gets more slippery, then chances are you're probably going to see more understeer. If it gets more grippy, then the understeer number is going to go down. I mean, yeah, go down,
It's
right?
just exaggerated by the lack of grip, but the same thing,
Right.
same end result is going to be there. I maybe for the task of car vehicle performance things that we're talking about here today, having a non-changing model like iRacing maybe does for you, this would be superior in what you're trying to do here with understanding, the things you've talked about today.
Right.
So.
Yeah.
Okay, perfect. The two things as we kind of close this down. I think we have. Does full fuel load affect the simulation? Do you
Yeah.
typically every time you restart it, you start at the same fuel load you left at the time
Yeah.
before?
Yeah. In this case, it was 30 liters of fuel,
Okay.
but yeah, if I doubled that, then yeah, the car is going to be heavier and it's going to affect how it handles.
And the fuel load burns as you make your 5 or 6 laps, but every time you
Yeah.
restart it, you just start right back where you were. So
Right.
consistency again, right?
Yeah.
Perfect.
Yeah.
Perfect. The couple. I'll just add one more thing that again, I'm no engineer. We went through this with my son a little bit. That rake change to me, the rake and the anti-roll bar settings would always make the biggest differences for me. We could tinker with the
Yeah.
shocks and I didn't get as much change, but rake was our rake and rear
Yeah.
toe on the Mazdas and the stuff we worked with was almost always the change we would end up going with. The rake ended up being a large change for us
Yeah.
always
Yeah.
in
For
all
sure.
cars
Rake
we
is a
worked
big
with.
one.
Yeah,
Yeah.
interesting. And then the kind of closing this out a little bit, I'll bring up the presentation in a minute, but talk to us about your thoughts on the real car, the feedback you're getting from. I know you don't have a GT3, but you're getting real feedback versus what you're feeling in the sim. What to kind of close this out, what is your gut feeling of how good has this sim work been for you, and how does that translate into the real car as best you can?
Well, it actually works really, really well because I had a Ferrari challenge car built for Assetto Corsa. So,
Uh,
so I sent the data to somebody and I worked with him to come up with a Ferrari challenge car that I use before every race weekend. And I'll go through a bunch of different scenarios and make setup changes. And the drivers use that car. And I can look at their data, and then I can actually bring that data to the track and compare it to real life data. And it's amazing how close it can be. At Indy, I think we were within like half a second or something like that of the time that our driver turned in real life to the time that he turned in the simulator. So it works really, really well. I mean, I've put a lot of effort into it too,
yeah,
but
yeah.
but yeah, I mean, it works quite well now.
There's nothing more valuable than track time.
Yeah.
And by being able to, you have made it in the class that you spend a lot of time in. You have made a tool that you can do on Wednesday night at 8 o'clock, right? And do some
Yeah.
engineering where you can't get the track, and track time is so valuable. So I just think it validates the entire process. You validated some setup changes that you can now try and then take to the track the next time you go and say, here's something that I think will help us in this
Yeah.
situation. Very, very valuable. And I hope everybody enjoyed looking at some simulation data and taking that to the next level. And even though simulation data, it's data is part of our analysis package here, where we're a little subgroup of webinars we've been doing of data analysis. It happened to be simulation data, but you can apply this to everything in your own cars as well. So I hope everybody enjoyed it.
Yeah.
So of course, this video will be up within an hour or so up to our YouTube site. This will be number 170 that we've got up there. Just almost invaluable information from so many great co-hosts like Ray that have helped us out. Take a look at it, go back, review some of the different videos that we've done. We've linked a lot of them here in the chat box. We'll link a bunch of them that we kind of touched into what some of the stuff Ray was talking about. We'll have those in the description box below, and click on some of those to get some background information on some of the stuff that Ray chatted about today. The we're really a customer support company that happens to sell racing electronics. One of the things we like to say, give us a call if you have any questions, any needs with your AIM devices. Make sure that you give us a holler at the 800 number, or emails, or whatever it happens to be. We want to help you get the most out of your AIM hardware and software. Our next webinar, our good friend Matt Romanowski has been has co-hosted quite a few with us, and Matt's going to come in and chat with us next Tuesday. A little bit of a different focus, but it's always on data analysis in this little subset of videos. We're going to chase a lap time in your own data. Matt's been working with a fellow that has agreed to share his data and video with us. And many of us, when we're out there, we don't have shared data from the track we're at, from the track conditions and all the different things. And we need to chase that lap time inside of our own data. This fellow that Matt's been working with has been doing that, and he's got a goal that he's trying to get to, and Matt's going to walk us through some of the things that he's done, talk about the data that he used to get there and some of the different tasks, and look at the data and look at the video and see how the Race Studio software and his AIM hardware has helped him chase this goal at it happens to be Thompson Speedway. So it'll be kind of an interesting take on our data analysis subset of webinars. We'll have a good time. So we look forward to having Matt join us next Tuesday, August 10th, same time that we have always done this. So looking forward to seeing everybody here for our 106th webinar. So back to your streetcar there, Ray. It's I think it's an iRacing simulation car there, right?
Yeah,
perfect. There's Ray's contact information, Precision Driving Analytics. Again, Ray has a number of services that he does, a lot of them remotely, right? So you don't, he can visit you out at the track, but he does a ton of things that he offers, through his website, setting up the, profiles and math channels and helping you look at data and do some different things at Precision Driving Analytics. There's his email address and his cell number if you need to chat with him and see if there's something that you guys can work out. If you have any questions about the webinar that we did today and some of the tasks that he did fairly quickly, we're always limited on time, so we go fairly quick, but assume you can go back and take a look at it on YouTube later if you miss something really quickly. So again, all of the data, the video, the presentations, the math channels, the profiles, even the track map is linked down below for you to recreate a lot of what you've seen today. Appreciate Ray going to all the extra work to do that. Ray, is there anything else you'd kind of like to share with us as we kind of close this one out?
No, just that this was actually just scratching the surface. So,
exactly.
I mean, I go a lot deeper for my clients, for the Ferrari Challenge team. So anyway, it's kind of fun to do it with the simulator data too, though. And, I use simulator data really to teach me what I should be seeing in real life data too, so there's a lot that can be done with the simulators nowadays. So it's a tool that's pretty inexpensive, so make use of it.
Certainly, and you also shared to take it even out of the simulator range and back into all of our users' regular data. Everything you talked about here can be used in data that they've gathered at the track as well. So a fantastic session. I appreciate you doing it, Ray. We will be inviting you back, and again, we only have an hour, so we fit in what we can. We understand that it is even more complex than this, but we're have building blocks is what we're doing, right? We just keep on building on what we've done in the past. So appreciate you being here. Thank you very much. Thanks to everybody that joined us live. Thanks for everybody that's watching later on YouTube. We appreciate it. Give us a holler if you need anything. And thanks again, Ray. I appreciate it very much. See everybody here with Matt Romanowski a week from today on Tuesday. We'll see you all then. Talk to you guys soon.
Thank you.
Bye-bye.